Lecture 48, Gradient, Divergence and Curl. Now the divergence is what? Divergence of a vector point function. So here, if we have a vector v, which is a function v1 I plus v2 j and v3 k, be the differential vector function. So this is what? This is a vector function where I, x, y, z are the Cartesian coordinate of v1, v2, v3 are the component of v. Vector v, then the divergence of v is denoted by div dot v, or we can say del operator dot product of vector, and is defined as del of the vector v, or some we write div of v, that is a divergence of v. So divergence is what? I del upon del x, j del upon del y, k del upon del z, and the vector v. Here v1, v2, v3 are the component of the vector v. So when we take the dot product, so I dot I, we get 1, so del upon del x of v1 plus del upon del y of v2, j dot d, j is 1, and similarly del upon del z of v3, and k dot k is 1. So here we have to note that if we operate that del operator on the vector quantity, so we get a scalar quantity, means the divergence of vector function is a scalar function. So please remember, the divergence of a vector function is a scalar function, and the previous, in the case of gradient is a scalar function. Gradient of a scalar function is a vector function. Here you have to note it that if v denotes the velocity of the fluid in a medium, suppose we can say v is a what? Vector point function, and we say is a velocity in the fluid medium, and thus if divergence of that v vector is 0, it means the fluid is said to be incompressible. And the second thing, in electromagnetic theory, if divergence of v is 0, then we can say vector field v is said to be solenoidal, right? So please remember, if divergence of a vector is 0, so we can say the field is solenoidal, or in the case of fluid, we can say the fluid is incompressible. Now we find the divergence of a function fxy, which is a vector function xy square I, 2x square yz, j, and minus 3y square yz square k at point this. So we have to find the divergence. So if you remember, divergence is what? Is an divergence of f, that is the del operator dot with the vector function f. So I del upon del x, j del upon del y, and k del upon del z dot the vector function f, that is x y square I, 2x square yz, j, and minus 3y z square k. Now we take the dot product, and as we know, I dot I is 1, so del upon del x of x y square j dot j, that is del upon del y of 2x square yz, and del upon del z of minus 3y z square. We take the partial derivative, so we get partial derivative of xy square, we get y square with respect to y of that function, that is 2x square yz. So treating x and y, x and z is a constant, so we write 2x square z plus, sorry, we get a negative sign, that is partial derivative of this is, we write minus 6y z. So this is what? This is a divergence of f. So here we get the scalar function. If we take the divergence of a vector, del operator of a vector quantity, or we say divergence of a vector, is what? Is a scalar quantity. And now we have to find at point at the given point, that is 1 0 2. So divergence of f, we get 1, sorry, 0 plus 2 into 1 into 2 minus 6 into 0, we get 0. So here we get 4. Now the curl of a vector point function. So the curl, or sometimes say rotation, is the differential vector point function, say v, which is v1i plus v2j plus v3k, is denoted by curl of vector v, or we write the del operator cross product of vector v, and is defined as the del cross v, or say curl of vector v, that is I del upon del x plus j del upon del y plus k del upon del z cross product of v1i plus v2j plus v3k. So here we have a cross product, so that is easily solved by the help of determinant. So we write I j k and del upon del x, del upon del y, del upon del z, and the component of v, that is v1, v2, v3. So on expanding that determinant, we can write in that way. So here we obtain a vector. So you have to note that the curl of a vector function is a vector function. And the second point, if the curl of the vector function is 0, then we say the vector, that vector v, is said to be irrotational vector. So here you have to note that when we operate that vector differential operator on the scalar quantity, so we get a vector quantity, and this is what this is this is the gradient of phi. When that operator we operate on vector quantity, so we get a scalar quantity, and this is what this is the divergence, that's called divergence of v. And when that operator is cross product with the vector quantity, so we get a vector quantity, and that is what this is called curl of the vector v. So you have to remember these 3 points, that is divergence, gradient, divergence, and curl. In the example we have given a vector v, that is x squared z I 2y cube z squared j and plus x y squared z k. Then we have to find the curl of that vector at that point. So as we know, the curl of v, vector v, is what? Del cross vector v. So in that case we use the determinant, that is I, j and k, del upon del x, del upon del y, and del upon del z. And now write the component of the vector v. This is the component of I, that is x square z 2y cube z square, and the component of k is x y square z. Now we just simplify or expand that determinant. So we write I, the partial derivative of this with respect to y. So we get 2x y z minus the partial derivative of this function with respect to z. So here we get minus 4y cube z. Now take j. So the partial derivative of this with respect to x, we get y square z minus the partial derivative of this with respect to z. So we get x square plus the vector k, and the vector k, the partial derivative of that function with respect to y, which is 0, minus the partial derivative with respect to x, we get 0. Now we simplify that equation. So we write I 2xyz plus 4y cube z and minus j y square z minus x square. Now this is what's the curl of the vector function, and now we have to find the curl of vector v at the given point, and the point is what? 1, minus 1 and 1. So the curl of v vector is 1 1, we get 2 plus 4, so we write 6i, and sorry, that is negative sign, so we get minus 2, that is minus 2, and this is again minus, so we write minus 6i and 1 minus 1, this becomes 0, so we get minus 6i. So this is the curl of vector function at point 1 minus 1. So in that way we find the curl of the vector quantity.